fast can I explain the basics of civil engineering? We're about to find out. So let's say we have a situation like this. We're trying to find the horizontal acceleration on this structure. And to calculate this, we're going to need to find a horizontal force. So we can use this by calculating the x component. The x component can be calculated by taking your force and multiplying it by the cosine of your angle theta. And the y component can be calculated by taking the force and multiplying it by the sine of theta. For this problem, we only care about the x component. So to calculate this, we're going to take our force of 50,000 newtons and plug it in right there. Then we're going to take our angle 30 and plug it in for theta, which should give you approximately 43,301 newtons. Now what we can do is use Newton's second law. I'm going to plug in our horizontal force right there. I'll take 5,000 kilograms and plug it in for our mass. To solve for acceleration, I just need to divide 5,000 by both sides, giving me that acceleration is this fraction right here. Evaluating this fraction on a calculator should give you approximately 8.66 meters per second squared, and that right there is the horizontal acceleration of this structure. Now let's talk about statics, and the equation you're looking at down here is the equation for moment. Moment is the product of force and distance. Whenever the force influences a clockwise rotation, we call that direction positive. Whenever it influences counterclockwise rotation, we call that negative. So let's try a practice problem. So we have three forces listed right here. What we need to do is calculate components for every single force. Now I'm going to start by using these equations on this first force. So I'll go ahead and take our 100 newtons and plug it in for our force, and then our angle of 30 and plug it in for our angle. So we have 100 times the cosine of 30 and 100 times the sine of 30. If you evaluate these on a calculator, you should get approximately 87 newtons and 50 newtons respectively. So this is your horizontal component and this is your vertical component, which you can replace this vector. So you should have this right here. If you go ahead and use the components on this vector, this should break up into these two components. And you can do the same thing with this force and this angle. This should give you components like this. So you have 180 newtons in the x direction and 240 newtons in the y direction. Now you have all your components. Notice that these forces are going to influence a clockwise rotation. This force can rotate counterclockwise. These two forces do nothing since they're across the line of action right here. So we can just get rid of those two forces. Now we're going to calculate the moment for each force. Moment is the product of force and distance. So if we do this for force 1, we have a 50 newton force and a distance of 1 meter. So we have 50 times 1, which is 50 newton meters. That's your moment for force 1. For force 2, we have 188 newtons times 3 meters, which is going to give you 564 newton meters for force 2. And for force 3, we have two components here and here. So what we're going to do is take the two components, find the moment for each one, and add them together. Notice something here though. This force is going to influence a counterclockwise rotation. Counterclockwise rotations are negative, so we need to make this number negative here by changing this to a minus sign. Now we have our equation set up. So I'll take the y component and I'll take the x component and plug them in for the two forces that I see, giving me these two forces right here. Now I'll take the perpendicular distances and plug them in for distance. Now all we need to do is evaluate this value right here. You should get 180 newton meters, and that's the moment for force 3, and these are the three moments for each force at the given point P. Now this right here is a crib sheet for fluid mechanics. That was a basic introduction to civil engineering.